Good afternoon, everyone, and welcome back to A4Q Testing Summit. I'm Atefa, and I'm happy to welcome Dmitrij Nikolajev, who is the testing lecturer at Vilnius University and also the head of the business unit at InSoft. Hello, Dmitry, and welcome. And today, Dmitry will be sharing his insight on codeless versus code-based approaches in test automation, benefits, challenges, and practical applications. Sounds interesting. Uh, I am so interested, so excited to hear more about that. But before leaving the stage for Dimitri, I just want to mention that we have an award for the best presentation and best speakers. So if you like Dimitri's presentation, please go and vote for him. Also, after this presentation, we have a QA session. So if you have any question, feel free to put a comment on the live stream and we will ask Dimitri. Thank you very much. And Dimitri, the stage is yours.
Hello from Vilnius. Thank you, Atefa, for the introduction. So today I'm here with you to talk about codeless versus code-based test automation. Before we jump into this, Atefa did brief introduction. I would briefly emphasize my background. Yes, I'm a testing lecturer at Vilnius University, head of business unit at InSoft, and I'm actively involved in various non-profit activities as a volunteer. I'm a president of the Association of Software Testers in Lithuania, and we run a local chapter for ISTQB. And I'm also actively involved in ISTQB Academia, work as a vice chair. So you can grab my profile, check my profile on LinkedIn. I have a QR code for that. And let's move on. One more important disclaimer before I begin talking about codeless and code-based tools. Just important statement that all references to commercial products, case studies in this presentation, even those based on real cases, are entirely fictional. Any similarities to actual companies, software, or industry practices are purely coincidental. With that being covered, let's talk about the topic. I love cars, and there is a cool car show which is called Fastest Car. The concept of this show is that there are car enthusiasts that use different cars, old ones, new ones, all sorts of cars that they modify and build to be a performance cars. And these enthusiasts are competing with a supercar, a top performance car, which is very expensive, high-end performance cars. And as a car enthusiast, I've decided to take that concept and try to apply it to the topic I'm presenting today. So let's make an assumption. Let's take two edge cases. Let's imagine we have a codeless top tier tool. I have written codeless in this manner to emphasize that this is a codeless tool, not like Selenium remote control. It's more a closed source. It's a feature-rich, closed source, commercial off-the-shelf tool, which comes with an yearly or any sort of subscription-based model. And on the right side, we have code-based, something minimalistic, lightweight, open source, custom-built framework, which comes with a zero software licensing fees. So let's take these two concepts for a drag race, like in this Fastest Car series. I've decided to split the drag race into 4 categories. As a person with a technical background, I decided to start with 0. So as a 0 stage, in a drag race, we need to warm up the tires to make sure that everything is ready. It's a preparation stage. Then we have a launch. A good launch means high chances for success. Then we accelerate and shift, and eventually, once we cross the line, as winners, we certainly want to be able to hit the brakes and actually stop. If we don't stop, we might smash our car. So let's go for a drag race. So warm up the tires and prepare yourself for the success. As an objectives of this stage, I've decided to point out three. We choose a tool or a set of tools based on some initial criteria. If the organization is, for instance, a Java shop or coding with Python or Microsoft, you might choose tools based on specific criteria or a technology stack you're using. Once you have the tools that you want to use for automation, you need to make sure that they are fit for the purpose. And the second point is build some proof of concept, or POC for short. Test different scenarios, different test cases, different approaches, depending on what the tool is capable for, to see how it is performing. And I have a third option, which I think is very important, not to stop with just a proof of concept, but actually do a pilot project. And here are the practical considerations why I think it is important to follow through these objectives. First of all, start small and fail fast. This is a concept borrowed from the Agile Manifesto, which I think fits in here perfectly to avoid taking a wrong direction and avoid having a high cost of taking that wrong path. It's important to build an understanding of the tool's capabilities in specifically the context of the organization, depending on what's allowed, what's not allowed, in terms of the environments, regulations, etc. There are many things to validate how automation works in your organization. Some tools are cloud-based, if that even allowed, according to the organization rules. Build competence and maturity. It's important to have competence and maturity with the tools, especially before you go for a commercial tool. You need to practice and exercise with the something maybe free or freeware or open source. Forecast return on investment, ROI for short. It's important to understand what are the values, and not just in terms of the cost, but also time to market, in terms of the quality and how we measure that. And it's important aspect of the automation. We need to have a vision how we do that. Educate the stakeholders on value, strength, and weaknesses of test automation. Decision makers, usually they are not testers, and you need to have a key how you communicate with them so that they are aware of the value. Now, we have a warm-up phase where codeless tools usually come with a trial license that has limited scope or limited validity time. Some capabilities might be hard to evaluate because it's a feature-rich package that might have a lot of tools around it, and to bring it to your environment might not be an easy task. After the trial ends, and if you have built a pilot, it would be probably hard to support it if you decide to test some other solutions, and your license would probably expire and you will lose your benefits. With the code base, you can start small, use even plain framework. You can build necessary capabilities, and you have to do that. It can take some time. And once you build the pilot project, you're okay to use it and support it going forward. So I would score 1 point and give 1 point in this stage to the code-based approach, because it is more flexible and has fewer constraints. Now let's go to the second, or in our case, it is a first stage of a drag race. It's actually launch. So let's jump to gain the advantage. So what we do, we build the framework. Depending on what tool we're using, still we are building packages, classes, methods, we are configuring execution, reporting. Some of it might come already out of the box with the codeless tools. Build the structure for a specific application. That's something where you still need to get your hands dirty. Uh, some functionalities of the codeless tools might help you out here, but still, you need to build some reusable test blocks, have some test design sheets, or depending on the context, have everything ready to go ahead with your application. And of course, create good examples how the automation should be carried out, let's suppose by less experienced test automators and testers. I make this joke that copy paste is still very popular test automation technique these days. So as we launch practical considerations, I recommend and emphasize that always, I think it's very important that test automation architects always go first. We don't want inexperienced automation people or testers without the automation experience to start building automation, because it's likely to be redone and might actually create a lot of not usable test automation, low value test automation, especially if that's high-end tools with a record and play functionality. That can be very dangerous. And I would like to emphasize that not everyone can become a good automation expert, regardless of the tool is used, regardless of the sales statements are made, especially by the vendors of the codeless tools. You still need to know some automation principles. So that brings us to this competition. With the codeless tools, indeed, many capabilities are available out of the box. It might have scanning, rescanning, already good features for feeding in the data into the test cases and managing it. Execution, reporting, integrations might be available out of the box, and it's quite likely. With the code-based tools, some capabilities still need to be created. Architecture and design have to be built, and execution and reporting integrations have to be built or reused from some other projects. So it still creates more hassle. So I would definitely give 1 point in this category to the codeless test automation tools, because they're typically feature rich and it's quicker to build good architecture and structure. We can compare it like it's all-wheel drive and they just jumpstart. Now, we came to a second stage, accelerate and shift. So full throttle ahead. And what we're doing at this stage, our objectives are to automate the tests. We have to start executing the scripts and start tracking the value. And of course, we need to do regular improvements, maintaining the framework, maintaining the scripts, maintaining the tests themselves, make it stable and robust so that we have fewer maintenance as we scale up. Now, practical considerations for acceleration. It's less is more. Keep it lean, keep it clean, and mind the maintenance. I think this is important, especially if you have high-end tools and you think that you will automate all of it. It still creates a need for maintenance. So the rule less is more is applicable to any tool. It's important to understand that automation finds specific type of defects like regression defects. Exploratory testing usually finds more defects. But while you're automating the scripts, it's similar to exploratory testing. You're actually exploring these test cases in much greater detail while you're automating, and you can find actually a lot of defects. So that's an added value activity. Automated E2E regression tests must be orchestrated. If someone is executing the scripts for the release on their own computer, you're in trouble. That's a bad practice. It has to be orchestrated or integrated into the pipeline. Test ops, DevOps practices, I think is a must in a modern test automation. And of course, transparent and visible reporting is the key to winning the stakeholders' hearts, especially if they are not with a testing background, if they are not technical themselves. They need to see the reports, and preferably simple automatic reports that they can either use online to drill down into the reporting itself and see the charts, or some simple graphs, charts, statuses sent automatically by emails. So practical considerations for shifting. Test automation architects have to be there to support, and we cannot afford losing these top guys, top performers that help the team enhance our framework, do the reviews, and refactor, improve, throw out unnecessary things, and make sure that we are safe to scale up. Upgrade cautiously, but always try to keep your stack and versions of the tools you're using, of the packages you're using, up to date. Calculate and communicate return on investment in terms of value and benefits. Let's not forget that. So in this stage, we have codeless tools that usually have built-in quite good, robust element selection strategy. What helps to make scripts more robust and less fragile. Usually it's all in one tool, and you have a lot of features. But there is a consideration that adding features can be quite hard to extend a commercial tool. Upgrading to new versions can be also quite difficult because it's a very sophisticated tools with a lot of integrations. You have to mind compatibilities with other software integrations and stuff. So that can be challenging in some cases. Good strategy for element selections is needed for the code-based approach. Usually you have no constraints to extend the capabilities. Go ahead and do it yourself or reuse some libraries. Basically, you have building blocks, you can build whatever you want. Upgrading to new versions, if you have a dependency management, that's probably an easier task. So here, I would still give 1 point to the codeless tool. Once it's set up and running, both concepts are good. Let's face it. They have unique pros and cons, but codeless tools can actually accelerate test automation more in certain situations, thanks to the rich functionality and all the integrations they are bringing. That's why I'm giving 1 point for that stage to the codeless tools. So the drag race is nearly over, but we need to maintain what we have or put it on hold or even retire in some cases. So while the finish line has been crossed, objective, how do we stop test automation? And here are some practical considerations. Well, consider the fact that the project can end eventually, that test scripts would need to be retired. Consider the fact that you would have to hand it off to other company or other team. There could be situations where project is for some reason on hold, and you will not be using the tool to run the scripts, or you wouldn't have to maintain the scripts. Imagine that you'd have a complex environment with the dependencies to other tools. So this is a licensed software in case of codeless tools. You have execution servers, maybe you have even a test management tool that is also integrated or provided by the same vendor. So there could be situations with savings and budget cuts where you would have to put it on hold. So with the codeless tools, you have the licenses, And usually with the licensing schemas, you have less flexibility, and there is less possibility to migrate your work products, especially if that's a very complex setup. With the code-based test automation tools, you can stop anytime. And of course, if it still works after you want to execute it. But in theory, if there are no changes to the application, to the environment, to the test scripts, maybe it wouldn't take a lot of effort to get it back running. But anyway, code-based tools, because they don't have licensing fees, you can put on hold for some time. And there is no vendor locking in this, usually in this case, since there is no intellectual property associated with the licenses. So for the breaking, I would give 1 point to the code-based tools. If you have the gaps in your projects, you need to do the savings. Maybe having a code-based framework is the better option for you. And once you go codeless, there is no easy way back. So that's why I'm giving this 1 point to the code-based test automation. Now, in my comparison, we have a draw. And of course, I did it intentionally. I just wanted to highlight the strength and weaknesses of both approaches based on the expertise I'm having. Which one is the winner for you? I think it's up to you to decide. And testing is very context dependent, and I think there are different scenarios where one approach is more beneficial than the other. I would like to quote Dorothy Graham and her presentation, Blunders in Test Automation. I've cherry-picked these 3 statements from Dorothy Graham. She says there is no such a thing as the best tool. And she calls it a silver bullet syndrome, and mentions that there are suitable tools. There are good enough tools, but not the best tools. With that being said, I would like to go through some myths and overstatements in codeless tools. With codeless tools, even business people can start automating. No coding skills are needed. Maybe phrased a little bit differently, but these are the phrases vendors and salespeople of the codeless tools are quite often using in different flavors and variations. Well, anyway, it takes time to learn any tool. And based on my experience, based on many cases I have seen, coding skills help testers to learn codeless test automation much quicker, since the same principles apply. How automation is conducted, how to reuse the components, how to use the parameters, what is the instance of an object, of a class. All these things are quite often still present in codeless tools, and it can be quite hard to grasp these concepts for those who have no coding skills or lower exposure to technical aspects of the test automation or development. So I would call it an overstatement or even a myth that business people can start. They can, but there are a lot of nuances to that, and the learning path is there. Codeless tools reduce the time and effort spent on maintaining regression suites. That's a very popular overstatement by the salespeople. They might be right. Indeed, some features can help reduce the maintenance, but if you're creating a mess with any tool, especially with the codeless tool, if you're just blindly recording your tests and you're never running your tests, well, that's going to end up with a lot of messy test automation. What actually makes uh, a good practice to minimize the effort, it's good test automation experts that put good architecture. If you make really good architecture, really good guidelines, really good naming convention, even with code-based test automation tools, you would have really low maintenance effort. It's a matter of design and expertise. Indeed, tools can support you in that journey. So I would say this is one, it was a definitely overstatement. Faster test case creation and execution through an intuitive visual interface. Faster test creation, I can agree with that. That indeed there are some accelerators that can make automation faster. If you have some scanning functionalities, rescanning, it can speed you up. But execution is something different. It's a matter of your execution servers, how many parallel executions you can have. If you have a lightweight framework and you can configure parallel executions orchestration on multiple servers, that's quite likely to outperform even a lot of feature-rich, heavy execution servers used by some codeless tool vendors. When it comes to intuitive visual design, some user interfaces of codeless tools are quite complex for the reason that they're extremely feature-rich. And learning it from scratch, I would argue that you can learn coding in some cases quicker depending on your educational background. And the fourth one, AI-powered features like visual recognition, self-healing, improve efficiency. I would say it is also an overstatement these days that I would argue with this statement and say that AI-powered features improve efficiency of sales in the first hand. When it comes practical application of AI tools, it's good innovation. Indeed, it's helping here and there, but quite often it's just a show off. I wish to see more practical applications. We, with the team, have been looking for these practical applications. We've been researching at the university where it actually gives value. So, my conclusion today is that in many cases, it is an overstatement or just a sales pitch. But definitely, I am not underestimating the importance of AI features. I think it is emerging, it is coming into test automation quite actively, and we will see much more in the future. So, with myth and overstatements covered, I have some recommendations for codeless test automation. What I've already mentioned, less is more. And please do not hesitate to retire those scripts that you are not running and the application is being developed, changing, and these scripts just sit there. Retire uh, if necessary. If it is failing, if it's not working, don't hesitate to retire these scripts. That doesn't make sense to keep. Continuously improve. Well, I would say these first ones apply to all automation, not just codeless. Review, it's important to do the reviews, peer reviews, reviews by senior automators, reviews by architects. Don't be afraid to redo what you have done, and it's important to communicate what needs to be redone. Sometimes business can see no value in something being redone, but it's a long-term investment to make sure that your scripts will require less maintenance in the future, or will be more robust, or will be more suitable for scaling it up once more functionality is added and you need to automate more test cases. Refactor and start over if necessary. If you need to start over with some new framework, there have to be lessons learned and take it further, justify what would be the value, and propose. That's why it's important to start small, fail fast, and continuously improve. Foster psychological comfort. I decided to include this option. Uh, it's important to have really comfortable, no blame culture and really listen to people so that they can communicate openly. What are their struggles? Why are not they are not automating something? Which task is too complex and maybe doesn't make sense to automate? So it's important to really have good culture. Uh, there could be a pressure when an expensive tool has been purchased by the company and there's expectation that there would be everything automated. That can create a pressure, and these voices might not be heard timely, which can lead to some inefficiencies within the organization. Fourth, I would say this is my favorite one. Do not blindly believe the salespeople. They might have no idea what they're selling. I had many conversations with different salespeople of the tool vendors. Quite often, they are not testers themselves. They know the buzzwords, but once they have a chance to make a sale, they would give you any promises. Uh, that's why it's important to do good proof of concepts, do good pilot projects, and salespeople are fun people to hang out with. But eventually, to make a right decision, you need to validate it yourself and maybe communicate more with the technical people. So, fifth, choose wisely. Investing in an expensive tool won't guarantee that you would be a good automator, that your testers would be professionals right away. Uh, it still takes time to learn and go through the transformation, to change the mindset, to gain expertise. Manage expectations. Number six, high performance is expected once you've chosen a codeless tool. Because it's expensive, because there might have been many promises by the salespeople. Maybe it was a silver bullet syndrome. Uh, it is auto magic what's expected. So it's important that expectations are managed, and the best timing for this is actually this warm up stage, burnout stage, where you can spin the tires, test this and that, and already have the competence and already communicate that to the stakeholders, um, what to expect from automation. And the last one, but not least, use it or you will lose it. Unfortunately, I know a lot of stories where a top tier tool was purchased by the organization, but it wasn't really utilized, or it wasn't utilized right away. Let's have this analogy with the race cars we had initially. Imagine you have a high-end sports car that you just park in a garage. Well, it's good to show off, but I think it's ultimately pointless. It's a luxury that only few can afford. We need to have that car up and running, and that's why it is important that organizations take the path by exercising their muscles, their skills with something more simple, even open source, code based. And once they have an understanding what would be the benefit of purchasing a high end tool, they can go codeless. And final thoughts from my side. Um, We've been researching different tools at the university. Students are giving the reports during the lectures on a variety of tools, and we're comparing these tools, their pros and cons. And we've been researching codeless tools, and I came to a thought: is codeless test automation really codeless these days? You can often run into some complex cases where codeless tools do not handle, they require you to add some custom functionality, and they quite often have some custom component where you would have to do some coding, for instance, JavaScript, write some JavaScript code. They even offer you co-pilots to help you do that. And I saw that, well, if you can extend the codeless tools this way, isn't code-based test automation actually becoming codeless? That was kind of a conclusion one of the students brought up. AI-based tools, LLM tools like ChatGPT or similar, make writing code or scripts really easy and fun. Sometimes you don't have to really be a coder. And in some cases, quite often, uh, test automation for code-based is actually codeless, that you can really generate a lot of code easily these days. So I think this industry is actually changing. I think codeless tools are experiencing a lot of pressure with the development of AI tools, because quite naturally, um, these AI tools helping a lot in the programming, in the coding area these days. So we'll see how the market changes. That's it from my side. Thank you, and I'm open for your questions.
Thank you, Dimitri. It was really insightful and a nice quote from Dorothy Graham. I'm pretty sure that our audience also enjoyed the presentation, and I can see we have some questions here. Um, which tools have larger user base, codeless or code based?
Well, I would definitely say that code-based is more widely used because it's more affordable. I think it's quite common choice of small businesses, medium-sized businesses, and even larger businesses. I'm pretty sure they have w- experienced that and went through that experience. Um, Many tool vendors that have great codeless tools, they publish their customer base, their user base. I would say it's primarily big businesses, enterprise level businesses. By naturally, it would be lower user base because I think it's the user base differs itself.
I see. Okay, and next question. Oh, actually, it was my question. What is your personal preference, codeless or code based?
Uh, I've kind of scored it a draw. Um, for me, as the person who has technical background, I do love higher level of flexibility and being able to do things myself and be in control. Um, how automation works, how framework works. So I do have a sympathy for code-based frameworks, but I'm not coding for a long time, and I'm more a manager. I'm coming from the managerial standpoint, and in practice, I do not care that much. I think there is a proper tool for a specific task, and the tool that solves the task at hand the best, I think, is the best. And there are many factors that the correct answer would depend. So I would say it depends. For me, for the company I work for Insoft, we are here to solve whatever task anyone has, regardless if it's a codeless or code-based. Uh, Everything works for us. As I
Many
said,
factors.
it's many factors, and I said, you cannot underestimate the importance really of good expertise and good architecture in both of these approaches.
Yeah, you're absolutely right. Thank you very much for sharing your insight with us. Again, if you like Dimitri's presentation, please go and vote for him. And if you found this presentation useful and you know someone who may need this information and insight, please share it with your friends, with your colleague. And the presentation is available on our channels, YouTube and Facebook, and you can share it with anyone that you feel that may need this information. Thank you very much,
Thank you.
Dimitri. And stay with us. We have the day full of presentation. Thank
Bye-bye.
you. Bye.
Software testers. Move beyond theory and master testing with the AI-powered ISTQB add-on practical tester by A4Q program. The ISTQB add-on practical tester by A4Q equips you with the theoretical skills and practical competence to truly excel. Learn how to apply black box testing like a pro. Estimate accurately, write flawless defect reports, and catch issues early. The ISTQB add-on practical tester by A4Q complements your ISTQB certification by turning knowledge into powerful action. Visit our websites and find out more information.